couple things from the end of the notes from section 7.3. The first is on finding domain and range given a logarithmic function. We discussed the basic domain and range. We said y equals log base anything of x. We said x, what I'm taking the logarithm of, has to be positive. It couldn't be 0, it couldn't be negative. And the range, when I take a logarithm, I'm going to get any number. I could get positives, I could get negatives, I could get 0. So the range for a logarithmic function is always negative infinity to positive infinity. To find the domain, we are going to take whatever we are taking the logarithm of, in this case x minus 11. And we said that what we take the logarithm of has to be positive. It can't be negative, it can't be 0. So we say it's greater than 0. Adding 11 to both sides gives me x is greater than 11. So the value is from 11 to infinity. Y equals log, or 2 log of 18 minus 3x plus 5. State the domain and range. Domain, we are going to take what we're taking the logarithm of and say that it has to be greater than 0. Subtract 18. Dividing by negative 3, so x has to be less than 6. All values less than 6, so negative infinity to 6. And the range is all values from negative infinity to positive infinity. And then the other part of the notes that we didn't get to last time is graphing logarithmic equations. Graph y equals log base 2 of x. Y equals log base 2 of x. You are much more familiar with exponential functions than you are logarithmic functions. So what we're going to do is we're going to take this logarithmic equation, we're going to change it to exponential form. We did that last class. Start with the base 2 to the y equals x. These two equations, remember, mean exactly the same thing. One is written as a logarithm and one is written as an exponent. So if I can get points on this equation, those are the same points on the equation we're trying to graph. They're the same equation, they're just written differently. So I'm going to make an XY chart. Because it's 2 to the y equals x, I'm going to plug in things for y. I'm going to plug in -2, -1, 0, 1, 2 for y. Get your x values. And now we have points we can plot. 1/4 -2, 1/2 -1, 0, 1. I'm sorry, 1, 0, 2, 1, and 4, 2. Another point, even though I didn't write it on here, 8, 3 would also be a point. It's okay if you don't include it, but I'm going to draw just a little better graph here. Notice we're never going to get to x equals 0. We get infinitely close to x equals 0, but we don't cross it. My graph looks something like this. It does ask us to state the asymptote. Notice a logarithmic equation has a vertical asymptote. I've got that vertical asymptote right here at x equals 0. Example 8, last one. Y equals log base 3 of x minus 4 minus 2. Start by translating. Translation works the same as it does with other equations. Right 4, down 2. Parent function, if I take out the right 4 and the down 2, I'm left with y equals log base 3 of x. We're going to make an XY chart for this parent function. Again, I'm going to change it to exponential form. think it's easier to think about 3 to the y equals x. Because we have 3 to the y, we're plugging in values for y and getting the x values. And then even though we plugged things in for y and got the x's, this is still the point. X is 1/9, y is -2. A lot of times I see people plot -2 1/9. I think because we plugged this in, we're reading that as the x. Don't forget to do your translation. We're going right 4, down 2. There's my translated origin. From there, I'm plotting 1/9 -2, 1/3 -1, 1 0, 3 1, and 9 2. Remember, we started with a vertical asymptote at x equals 0. If I move that down 2, that doesn't change it, but moving it to the right 4 does. Our asymptote is right here at x equals 4.